Hi guys, welcome to our fourth webinar for 4th of June 2020. We're going to have a fun time today with we have a guest speaker later on, and today is going to be all about serverless. We're also going to be covering a bit about Knative. Of course, serverless we have Cloud Run, so you can't miss that. How are you doing, Horizon?
Yeah, I've been doing
Like
quite.
the circuit breaker lifted, or not lifted?
It's not fully lifted, man. I think it's like phase 1 out of 3 for this whole like circuit breaker reopening thing. Yeah, and then like I guess at least in Singapore side, things are slowly opening up. Like you can see more activities around the neighborhood. I guess it's a good thing now that like there's less restrictions around, but with all things considered, like I guess we all still need to be careful. I mean, like just because like it's reopening doesn't mean it's gone. I mean, it's still there, right?
Yeah, that's true. Like I think right now, yeah, many things has been relaxed. I think in public transport they have removed the what do you call it, that separation sticker, and now that even though things has been so measures has been loosened, we should still keep a watch out, stay safe, and stay alert. Yeah, and we'll put through this together. I mean, 3 phases. Hopefully, we'll be done by the end of this year. We'll start having more physical meetups. But yeah, I think in the meantime, we still have like all these online meetups. I think that you guys can come and join us on. Yeah, but I've been kind of enjoying this online meetups format for quite a bit. Like I posted a picture recently on me actually cleaning my keyboard at home while watching another meetup, like this online event. So I just took out the whole thing, clean it, and watch it at the same time. It's kind of efficient in a way. Like you can do like whatever you want while you're watching.
Yeah, and what's more, like this webinars thing, I guess like a whole bunch of meetup groups all started like really going sometime this month. So I don't know. It feels too many. There are too many groups doing meetup nowadays. It's like playing a catch-up game. Like, okay, which meetup can I go today? Like it's almost like a daily thing nowadays. Yeah.
All right, so maybe we can get started with our topics proper today. So let's jump right into the same thing we have been doing, and hope you guys have been enjoying it. Let us know if you have any feedback on this segment. So Human RSS will give you an update on all new things that we've discovered, all curated stuff, exciting stuff, new tips and tricks that you can sort of practice on in using GCP. Let's get started with the first part. So, what are the new updates that we have today, or within the last few weeks, Horizon? So, regarding GCP.
Yeah, so I mean, GCP has like I guess been on the ball lately. Like it's like new feature after new feature after new feature. Some of them may be of interest. Like okay, like the first one that just popped up here is Google Cloud Functions. Google Cloud Functions, as you know, is a serverless service, and like today's theme is like serverless. So the first news has to be like serverless related. To get the serverless hype up. So Google Cloud Functions now has Java 11 support. I mean, previously it had Python, I think Go, and definitely all platforms usually have Node.js as well. But
Right.
now you have Java, Java 11 in particular. I mean, because like Java 11 is like a long-term support kind of version of the language. So I guess this is kind of to be expected because like there's a lot of companies out there that's still using Java. So I guess this is kind of a way to entice more people to come in. But I'm
Mm.
not sure. I'm gonna basically I don't play with Java myself, so I'm not sure how. Like, is there any intricacies with this specific feature? Like, who knows? Maybe like you need to configure your memory portion for this Java app in a certain way. I'm not sure how you even configure your Java configuration. Like because Java has this like thing where you need to like set the amount of memory or stuff like that. So I'm not sure how that plays out with this. So yeah, that's this one.
Mm.
Then I guess we can go to the next one, which is backup option for SAP Hana. So this essentially is not exactly a new feature, but more of like this whole thing about Google trying to support more of the enterprise customers out there. So as if you're not too familiar with it, SAP HANA is essentially a really big enterprise database. It's more like an e-memory database. Like it has like really great performance, but the requirements to run it is really high. Like the amount of memory that you require is like uh, you look at it and then like oh,
Something
but I
like,
mean yeah,
we say something like Anthos, like enterprise at that scale.
yeah, like you need a lot of budget for it, but I mean I guess you need that because like the amount of data at that scale is like really huge.
Mm.
So SAP HANA, like as like now like they're trying to get like people who run these SAP HANA databases into Google Cloud, and then like with all databases you need to like ensure that you have a proper backup to all this data that's residing in SAP HANA.
Mm.
So this article kind of details on all the aspects or all the ways you can do this backup on SAP HANA. Like one of the main thing is definitely to chuck it into Google Cloud Storage. That there are links within this article that shows how to do that. But yeah, I mean that's kind of all the most of the thing I can say. No, I'm not too familiar about running SAP HANA here. Then next one, Cloud Functions. I think last week we did mention about Cloud Run having VPC, which is like exciting news, at least uh, to me. I mean, because like I do use Cloud Run quite heavily, but now Cloud Functions has this VPC support as well, and I think the mechanism is about the same. I think using the serverless connector, if I'm not wrong, but do check the article here. It should detail that all that specifics. Yep. And then the next one, so there's this thing about Hadoop clusters, and like Google having this Hadoop related product called dataproc or something.
Mm.
So dataproc is, I guess, is Hadoop on GCP, I suppose. But like if you were a user of Hadoop in the enterprise, like you wouldn't want to like migrate all your data over just because GCP has it, because there are worries like after you move your data and then like what if this dataproc product not popular, then like the whole thing like GCP suddenly shuts it down or something. So there's that worry. So instead of using dataproc as like to store your data, instead now let's say if you have this like massive data workload that you need to run on your Hadoop cluster, but there's not enough resources to run it,
Mm.
you can extend it out to this data proc thing that is residing in GCP. So you can like utilize you like like let's say this analytics workload is like very bursty, you need a lot of resources only for that one short moment. It doesn't make sense like to extend your Hadoop cluster on premise, right? Yeah, it makes more sense to actually just rent out some nodes from GCP to just extend it out just for that little moment, and then that once you're done, like return the nodes back, like you don't need it anymore. So this article kind of details on like the aspects of that and how you can approach to this. Yep. Then let's see what's next. Next one. So there's this thing, this Anthos thing that has been like going around for a while. So I mean, the like this news is interesting and all, but this thing was more added here because of the technical details in the article rather than the actual product news itself. So if you are not too familiar, so running Java on Docker isn't that pleasant of an experience. Like, I mean, if I'm not sure, like, do you play around with like putting
So
Java?
you talked to me about this previously, so yeah, I remember part of the story.
Yeah, I was like grappling a little about it. So there's a few reasons why Java don't really play well with Docker. So essentially, Java was created in a time when all these cloud stuff don't exactly or they don't exist as the way they are. So when like Java, the usual Java that people run nowadays, like Java 8 or something, there's the long-term version. So so for Java 8, right? When you try to stuff a Java 8 application into a Docker container, you'll see that it tends to fail quite often, and then the way it fails is because out of memory. So reason for that is because Java, it has this runtime thing, and this runtime thing is not like C groups aware. Like it is like you can't exactly restrict the amount of resources that it should take. So like Java itself doesn't know about this whole C groups concept or whatever. So essentially, when you try to run it, it just takes as much as resources as it can from the system. And then when you realize that, when Docker realizes that, hey, this Java app actually took too much, I'll kill it. So it just goes in that whole loop where the Java app starts, and then the Docker kills it because it takes too much memory, and then Java app restarts. Then it's like a crash loop cycle, like forever never starting. So this article kind of links to a few tools or technologies that kind of like help to solve this problem. So there's this thing about what they do is there's this LXC file system of sorts, which kind of mounts the C group stuff into the /proc file for folders, and that kind of helps to get Java to be aware of that. Yeah, so I'm probably butchering the explanation here. So I think it's better to actually just read the article and read the content pages about it. So it's a pretty interesting way to kind of solve this, because this whole migrate for Anthos essentially Google is trying to get customers to be interested in container technologies, but these Java applications are on VM. So like having this information would definitely help for some people, especially if you deal with enterprise apps, which is like Java related. So yeah. And then one more new feature. I mean, I guess this is more like an addition to Data Studio. I think last week we have another guest speaker, a speaker, Akhilesh. So Akhilesh did cover about Data Studio, but he didn't exactly mention about this kind of new feature in Data Studio, which is the Google Maps. So if you see our previous webinar, when you see that he clicked on the list of charts available, then you see that there's actually a map there. The map is actually a new feature, announced like this month. So it basically allows you to add maps to Data Studio dashboards. So that's a pretty interesting thing, especially if you are doing visualization based on stuff that happens in the world that is like geo related.
Okay, let's move on to the next one. Okay, so before we jump to the next one, I think someone has a question in the audience. So maybe I'll just flash it up very quickly.
Serverless, as you mean, instead of using your own local machine or computer, company one, you're using the cloud where, yeah, I mean, there's this whole thing about serverless, like, is it truly serverless? Like, do you not need servers to run this thing? At the end of the day, this whole serverless thing essentially like is trying to get developers to just focus on app. Like that's the whole main thing, right? So you don't want your developers to be like so muddled about your development pipeline, your deployment pipeline and that kind of stuff. Like it'll be best if the developer just focus on the main feature set, which like for most of the time like that's the main thing that they're interested in. So this whole serverless thing is like basically trying to like make things as simple as possible. So like you have cloud functions, which you just focus on application functionality. Then you just throw it to the cloud, and then the cloud has this certain pricing model that that kind of entices you to use it. So yeah, I mean things do run on server, but it's now someone else's problem. Yeah.
I think just to add on to what Harizon mentioned, I think interpretation of serverless is I would say there's no there are some fixed definitions, but it's not that like tightly there's not like one single like serverless thing in the world. Like if you look at GCP, right, you got Cloud Run, you got App Engine, you got Cloud Functions, and if you stack them up like along all those like IaaS service, PaaS, SaaS, you find that like they're actually on different levels as well. Like in terms of let's say Cloud Run, you're actually looking into as in you can control the OS as well. I mean in terms of the Docker image. But if you look at Cloud Functions, you don't care about that. All you care about is like the language you're doing in and just one single entry point. So the definition, I would say the broad one that I understand and I like to share as well is that infrastructure concerns, things like the actual server racks, the operating systems, those are taken care of by the providers. Okay, and then at the level, so that's more for hardware. And then in terms of you spinning up your applications within these environments, you have other concerns as well. Other concerns like load balancing, scaling it up. So these concerns are also taken care of by the provider. Not just hardware, but also on the end of being able to scale up as well as load balance your solutions. So in fact, like what Harizon just mentioned, you are just focused on one thing, which is just an application. You want to just look at moving an application or deploying applications and getting people to use them, whereas every other concern is taken care of by the cloud provider. Yeah, okay, so let's move on from this part. Okay, moving on to the second part, which is tips and tricks. Okay, so I think one thing that I'm very excited to share is this Google blog post. So you can actually go see this blog post after our webinar over here. It's basically an article explaining about SRE principles. And I'm just going to run through it very quickly. So there's 3 key points to this article. Basically, the 3 key points in terms of reducing or alleviating production stress over here. The first part is a step that you have to do on a daily basis. Okay, not saying before before today, but rather like at any time before any incidents occur. And the idea is to avoid toil, TOIL. Okay, basically the idea here is, for example, things like manual work. Every day you are turning on and off this switch, you're restarting this server because something goes wrong. Like you can't be doing that every single day. You can't be doing like 10,000 manual steps of this every day. You need to look at reducing some of them, automating some of your operations. Okay, I think in the SRE book by Google, they mentioned something along the lines of like not doing more than 50% of operational tasks every single day. If you are doing more than 50% of this different manual tasks every single day, you're not putting enough effort or enough time and resources for yourself to actually allow your own operations to scale up in the long term. Okay. And another thing that they mentioned, again, doing before, which is, or rather on a daily basis, which is eliminating bad monitoring. And what this means is that, you can set up your telemetry in a very comprehensive manner. You can collect every single stats that you want on your servers. But what exactly are the important things? You collect all of them, you make them set, a bunch of alerts to you, you receive the phone calls, but then does it mean it's effective? Are your engineers waking up every single night, to turn off this alarm that has been triggered and it's not constructive at all? So essentially, this can actually increase the stress, not just for your work done, having all these tickets piled there, is your KPI doing well, but also the engineers, they are very tired, they're doing a lot of these things, but it doesn't contribute to any value, towards your operations within your applications itself. Things like if the 4xx increase, does it mean it's your problem? Like maybe it's just people going to the wrong pages or typing in wrong things at times. And then accumulating to all of this, the last part is sort of a process that runs through, what you have to do before, what you have to do during and after. Essentially, incident management. For example, before you want to establish good communication channels, make sure that your engineers can be easily contactable, and also making sure that let's say if during the incident itself, for example, as a junior engineer, I am not sure on what to do. Maybe there isn't a playbook for resolving a certain error. I should try and find for a more senior engineer and try and get them to help to resolve this issue. Even if it's 2 a.m. at night, I tell this to some of my engineers as well. There's no point like trying to hang on to the problem for a few hours and you realize that you can't do anything about it. Sometimes it's better to collaborate. Not knowing something is sometimes okay because you still learn as you face these new bugs as you go along. And also, after those incidents, what you do after that, postmortems. But it's also important to have blameless postmortems. You don't want people to be afraid of having these incidents occur. Of course, you want to try and reduce these incidents from occurring, but you don't want them to be so stressed up that they don't even want to report these incidents when it occurs. You want people to be open about things when it happens, so that you can also find the correct solutions to solving each one of these different incidents. Okay, and I thought it was really interesting. If you read through this article, at the last part, right, they link it back to their own SRE book, and that chapter itself, they actually sort of, I would say, okay, for lack of a better word, they sort of glorify the incident management like culture in Google, where there's one part where they mention like they will sort of curate all the incident management reports, and they will find the best one that's the the best to read and send it out to the whole company to read, for that month itself. So it's kind of interesting that they actually try and encourage people to do it. And I think that if you are someone who's trying to build like this DevOps, this SRE culture in your company, this is something that you should check out to see, how you can improve what you have in your current company. Okay.
Yeah, I want to add on to that just now. So
okay.
I think if I'm not wrong, Stackdriver has like a set of features within it that kind of help you deal with the incident management. I mean, because at the end of the day, like just now you're mentioning about playbook, right?
Yes.
The playbook definitely need to exist somewhere. So I think Stackdriver does have a feature where like you can you can put it together with your alarm. So when the alarm goes off, this playbook is immediately visible to whichever engineer that is like looking at that alarm. It's like, okay, so to solve this alarm, I need to do this set of steps. So yeah, I mean, yeah, I just want to add that point to this.
No, I think that's very good because I think one of the issues that we face at different companies is that for first-time engineers who are going to be on call, there's never going to be a situation where you have the senior engineer and the junior engineer both together, at all times. Like let's say it happens at 2 a.m. at night. That junior engineer is not going to be like, okay, is my senior engineer just right beside me? I mean, so it's good to have like some playbook for them to start running through. So I think that's another very good tip. Should always have some. I mean, if you can and you have faced like similar issues before, do set up like some playbooks and allow newcomers especially to know what they can do. Then they can also learn from it in a constructive manner. Okay, let's move on to the next part. So this next part is actually a video that was sent out it was in the circular regarding I think some GCP event, and I thought it was very interesting because for most of us, even if you are like the DevOps personnel in a company, or let's say for a regular full stack engineer, backend developer, you might not actually come across this knowledge before, and I thought it was a very interesting watch, to understand how you can how do you perform different organizational access control, or how does organization level configurations work in terms of GCP. And so they'll go through 3 different things, which is how do you purchase and validate a domain. So this is the domain that's used for your company. Okay, and then creating the access control user groups. You have DevOps groups, you have regular, maybe the front end groups, the back end groups. So different groups for different resources. Okay, and then creating the policies for each of these different user groups. So again, at some of our levels, maybe we'll never get to touch these different organizational controls. But I think this one does give a lot of good insights on how you can, or how it is supposed to be done. They give like this walkthrough, in fact, of the actual console on how the domain is purchased up to the point where you create the groups and setting the policies. So it's actually a very good watch. Okay, let's move on to the next part. So after the new stuff and the tips that we have to share with you on GCP, let's talk about the community content. And the first one I'm particularly excited. So this is actually my colleague at Vicky who embarked on this journey where you can read up on his Medium post, where this is actually inspired from a different person who did this resume challenge, but it was actually using AWS tools. So my colleague did this, Kwang did this challenge where he used GCP instead of AWS and managed to create a site to represent his resume using different tools in GCP. And he covers a wide array of tools that's within the ecosystem today. So give it a read, just to see the different motivations as well as why he used these different tools, right, for constructing this one site. Okay. And there was also this other very interesting article that we found, which is in regards to, okay, basically the premise of this entire article goes like this. If let's say you have some workflow, coming from a Slack channel, for example, if you're using something like ChatOps, okay, and then this workflow is supposed to be reaching out to, let's say, some cloud function, and cloud function towards some heavier workflow. For example, if you need to process something using Cloud Vision API. So the issue is this: if you have you've created an application before, you have run some HTTP requests, that there's this thing called timeout. You can't just let your request hang there for a very long time without resolving. But some of these workflows on GCP essentially needs a long time to be resolved. So if let's say I send this one single signal over to GCP and it doesn't finish, like let's say within a couple of minutes, okay, on your end of Slack, right, in fact, you would have a timeout. Okay, so this guy, right, basically what he did was that to resolve this problem, right, he did it in sort of this asynchronous manner where you just make one call to a Cloud Vision, which sends out this job asynchronously, and then immediately resolves back to Slack. Okay, and then this job will run by itself. Okay, and once it's done, it will just trigger another Cloud function to send the message back to Slack. So instead of using one Cloud function, you use two Cloud functions instead. So it's quite an interesting read. I think it can be a kind of a tip as well if you want to look at building a workflow for asynchronous related jobs. All right. So let's move on to our last part of Human RSS, which is regarding Learning Corner. So what are the tips that we have to share with you today in terms of the different things that you can use to learn about GCP? Okay. So the one big thing that I'm very excited to share about is in regards to certification news. And I think some of you all might also have known that you can actually take the certification online now. So if I think there is this thing going on where you can you have to register by the end of this month, June 30, 2020, where you can get like a 30% discount for the examination fees, for the Associate Cloud Engineer exam. Okay, so just to go through the steps on how you're supposed to do it. Okay, so go to this site, Google GCP Cert Offer. And then, so once you go to the site, you scroll to the end of the page or close to the end of the page, there's this register model where you're supposed to select, you can see over here, it's a little bit small, but basically the option over here is Associate Cloud Engineer. Okay, there's three options: Associate Cloud Engineer, Professional Cloud Architect, and Professional Data Engineer, I think something like that. So three different options. Make sure you select the Associate Cloud Engineer one. And once you have submitted this with all your information, they will send you a ticket or email to a 30 days free GCP, as in not GCP, but Quick Labs, this code. Okay, so you can use it to practice on Quick Labs. They actually, within the email itself, they also will send you this document where they'll show you like sort of a lesson plan, a recommended lesson plan that you can go through to prepare for your examinations. Okay, and then after that, once you have the 30 days, that code itself, okay, you can just go to Quick Labs, complete the cloud engineering task, okay, and then they should send you this separate email or something like that for the discount code for your exam. So before you before you sign up for exam, or rather, to sign up for exam, you actually have to go to a different site to do that. So you should be able to use this code to get that discount. Okay, so after that, just take the exams and share with us your good news if you go take these exams and you get the certification. Okay, so beyond certification, what else do we have to share? So another thing, we're going to be keep blasting about this until we get to it. We're very excited about it. This is going to be coming in July, which is Cloud Next. So we couldn't do it in April, but they're going to do like an awesome 9-week program instead. And starting from July, July 14th? July 14th? Yeah, July 14th. Okay, so there's going to be, as I mentioned, 9 weeks. So 9 weeks of different programs. You can see over here, each week they're doing something different. Week 1, industry insights. Week 2, productivity and collaboration. So every single week there's something different, for each one of us. So if you are not interested in certain weeks, you can choose not to attend the online events that they have over here. Okay, so yep. If you're interested in this, do sign up over here, cloudwithgoogle.com /next/SF. Yeah, I'll leave it for a bit here if you need to just take a screenshot. We'll come back to this later again as well. Okay, and as courtesy from courtesy of our current speaker today, our guest as well, she shared with us a link to a free 30 days to Quick Labs. So this is independent of the earlier cert offer that I mentioned earlier on. So I tried this yesterday as well, and it works. So do go to this link and try, with this code over here, 1M Free Labs 372. You'll be able to get the 1 month free. This code will give you a 1 month free subscription to Quick Labs for you to prepare for your certification exams. As mentioned earlier on. Okay, so this is what we have for today's iteration of Human RSS. So let us know if you have any comments in regards to this segment, or if there's any exciting news, share within the comments. We can also share with the community later on. So up next, we have our guest speaker for today. So we have Singing, who is a software developer at Anchor. And today she's going to share with us her experience regarding serverless. So let's welcome her. Okay, so I'm going to add her to our stream. Hello, welcome.
Hi, everyone. Thank you for the warm welcome.
Okay, so let me add her slides to the stream. All right, so we'll hand over the time over to Singing into our topic. So yeah, take it away.
Great. Thanks, Ryan. Hi, everyone. So hi, guys. Today I'm Singing, and today I'll be talking about serverless containers with Knative and Cloud Run. Now, if you're not familiar with these terms, don't worry about it, because this is a fairly beginner level. So we'll be going through each of the terms soon. So in this talk, I'll be talking about what are containers and why are they important. You might have heard of them before. And how you can orchestrate the containers with Kubernetes. And then if you want to do serverless containers, you can do that with Knative. And if you want to manage serverless containers, you can also use Cloud Run, as we mentioned before. So in the past, when you're running, even now actually, when you're running and building applications, you might run them on top of virtual machines. So this is essentially what the virtual machines will look like. They are this part. So you have your own the application, the related binaries running on top of a guest operating system, which is your virtual machine here, and the virtual machines on top of hypervisor on top of your host operating system, which is the actual physical server, for example. The problem with this is virtual machines can be quite large. They can be several gigabytes, and there are actually parts of the virtual machines that we don't really need, like the guest OS, for example. What you really want when you are running and building your application is really just the app and your library, your dependencies, etc., right? So what if you remove the guest operating system? So that's where containers came in. So the people started using containers. Containers are essentially the application coupled with the binaries and the dependencies. So they run on top of a container runtime. And as you can see, they are, without the guest operating system, they're actually a lot smaller. they can be several megabytes, for example, compared to several gigabytes. So a common example of a container is Docker, which we'll be talking about a bit more about later. And essentially, how to run a container is you have a Docker file. The Docker file is essentially a declaration of what goes into the container. So your app, your binaries, your dependencies, etc. And you would build a container image from the Docker file and give the container image to a container runtime, which would then generate a container from it. So containers are more lightweight than virtual machines. They come with their own dependencies, and they can run anywhere with a container runtime. Doesn't matter on your local computer if you have Docker engine installed. If you can run it on your private servers or even on the cloud. So now hopefully you're convinced that you want to give containers a try if you haven't been using it already. So how do you actually use the containers when building and serving your applications? Let's take an example. Let's say you're making a fairly basic, maybe e-commerce app. You have a front end and you have maybe an accounts part and an inventory which takes care of the stock and updates your front end accordingly, say if it's out of stock or not. So because these three services are can be quite decoupled from each other, you would create containerized containers from them. So you containerize the app. So here we have three different containers. Inventory container, one for front end, one for your accounts. It's nice to have them separated because of traffic. Different containers might scale differently. For example, your front end is the part that's exposed to the customers, right? So you tend to have more traffic that way. So you might want to scale your front end container independently of the other containers. So maybe your front end, you'll have more instances of it, inventory of less, and accounts even little, because only people from your company would use it. So now that you have a good game plan of what containers you're going to use and how you're going to scale it, what about how do you manage the actual containers? So your containers have to run somewhere. So that means there are actual physical servers somewhere around the world, or maybe your own private clusters where you'll be running your containers on. But the thing is, if you have a lot of servers, you have to know where each container is at any particular point. Are you running it on this server or the other server? Where's the container at any one point? You have to make sure enough instances of the containers are available, and if one of the containers maybe they fail, you'll have to spin up another instance, for example. So maybe for a few servers you can do it manually, but obviously who wants to do that? You want to architect away the toil. So here comes Kubernetes. Kubernetes is an open source system for automating the deployment, the scaling, and the management of containers. It does a lot of things for you, and it provides a lot of the building blocks. But here are some main ones. It provides horizontal scaling, meaning if you need more instances, then you can spin up more instances. It does automated rollouts and rollbacks. So you can roll out, whenever you have a new version, you can roll it out, and you roll it out gradually so it doesn't stop your service in the middle of a production workload. And you can roll back if there are any problems. It does self-healing. So there's something called health checks. So if any of your instances fail, it would then spin up another one somewhere else. So now you know a bit about Kubernetes, but how do you run the containers? This is a container plan that we've talked about previously. How do you run it in Kubernetes? So Kubernetes, a cluster, this is a very simplified view of it. Essentially, you have a control plane, which manages nodes. The nodes are physical or virtual machines, depending on how you configure the clusters. And what they do is the control plane then deploys containers on top of something called pods. We'll talk a bit about that later. It will then run the containers on top of the nodes, essentially. So the nodes are your the servers that we've mentioned before. Maybe let's say in this case we have like 3 servers, and the control plane manages them. So next thing you want to do is you can't actually run the containers directly on top of the nodes, you have to encapsulate them in pods. So pods are the smallest unit of deployment. So you try to keep pod containers that are related together in the same pod. So some pods, they might just contain one container if that one container is all you need to run a particular service. But sometimes you might need more than one container. Let's say, for example, the accounts container, it depends on another container to maybe fetch something from another database or something. And it might have something else in it. In this case, we have a volume. A volume is another Kubernetes object that is essentially a local file system. So it allows the transferring of files between the two containers. So you can see some pods you have one container, some pods you have more than one. So now that you know how you want to structure your pods, you want to give it to Kubernetes to run. So you define your desired state. So in this case, maybe I want 2 blue pods, and 3 green pods, and 1 orange pod, for example. Then I've got the sample. And you give that desired state to the control plane. The control plane would then provision the instances on top of the nodes as needed. In this case, it will spin up the pods on the nodes. So this is what it will roughly look like. Maybe some of the pods, they'll go to first node, some to the second, things like that. The control plane will take care of that, so you don't have to worry about it. By the way, the desired state itself, it's another Kubernetes object. You're actually passing YAML file, which contains the desired state, and it's called a deployment object. So you pass a deployment object to the control plane, which would then spin up the pods. And another cool thing is health checks. So if one of the pods dies off, the control plane will then spin up another instance somewhere else, because it will try to maintain the desired state. It tries to maintain that there's always 2 of the blue pod, 3 of the green pod, etc. So you keep working to make sure all these pods are active. So that's a fair amount of new terms if you're not familiar with Kubernetes. So there's pods, there's nodes, there's deployments, volumes, and then there's actually other things about services, ingress, etc., that we won't go into. So Kubernetes is quite complex, which is a good thing, because that means you have a lot of flexibility when building your own applications. There's a lot that you can do, and you can even write your own custom resource definitions, for example. But sometimes you don't want all this. Sometimes all you really want to do, you don't want to handle, you don't need several containers in a pod with shared volume, for example. All you want is to pass your container off to someone who would just manage it for you, someone who would auto-scale it as necessary. So there's a high load increase, if there's a low load, they decrease. So it'll handle all the infrastructure for you. So what do you do in that case? Knative is something that you can look at, it's something you can look at. So it's an open source platform which is installed on top of Kubernetes. So you do need to have a cluster that's active, and you have to install Kubernetes on top of it. You have to install Knative on top of your Kubernetes cluster, and in fact, also you have to install Istio, service mesh. So what Knative does is it runs the container serverlessly, but it's still Kubernetes under the covers. So if you still, you can run serverless workloads, but if you still require the full Kubernetes version, it's still there, you can still use it. So Knative is divided into 2 main parts. So that's the eventing and the serving. So we'll talk about eventing first. As you can probably garner from the name, it's basically deals with events. So it can be triggered whenever there's an event. It's based off the cloud events, which is open source specification, which is handled by the CNCF, Native Computing Foundation. So for example, so that means different companies out there, different cloud providers, they write their own cloud events. For example, Google Cloud has some, AWS has some, etc. So for example, some cloud events from GCP is, for example, if you receive a new message from PubSub, the publisher, the messaging system. So you can, if it receives, for example, a message from PubSub, PubSub works, if you're not sure, essentially you have a topic, and people can publish messages to the topic. If a topic is a new message is published to the topic, anybody who subscribes to it can then receive the notice and the metadata, for example. And in this case, it's using the push version. So if it receives a new message from PubSub, it would then push to the Knative, and it would then be triggered, and then you'll run the container for you. So yeah, essentially that's eventing. Something's triggered, and then it will run, the Knative will run the containers for you. So another thing that another cloud event that GCP offers is using GCS, so the Google Cloud Storage. So if you have a new file uploaded, you can set it to trigger Knative as well. And there's also Cloud Scheduler, which is like a cron job. So you can trigger it at certain times. And there are also other triggers from cloud providers. You can have a look at the Knative documentation for more triggers. So that's venting. What about serving? So serving is essentially handled by Istio. So what it does is, one thing, it manages revisions. So if you have different versions of a container, it would be able to handle that, and you can split the traffic between them. Let's say for Canary build, you have a new version of your container out. You want to make a Canary deployment only run some of the traffic on top of it, on top of the new version. You can do that. You can set maybe 20% to the new version and 80% old version. And if you're not happy, you can always roll back or just roll it out to full. It does auto scaling for you. So if you have a container, you don't need to worry about not provisioning enough. It would auto scale instances as needed. It also scales to 0. And one thing you need to remember is Knative is not magic. You can't auto scale to infinity. It does run on top of your Kubernetes clusters, so you have to make sure you have enough resources provisioned. So there's also something called concurrency. So it handles concurrent requests. So if you have multiple requests sent to the container, you can handle more than one request at the same time. Great. So if you want to use Knative on your own clusters, you have to make sure first you need a Kubernetes cluster. It can be a private one. You can run it on top of GKE, for example. Then you have, or actually you can run it anywhere. Anywhere which has a Kubernetes cluster, you can run it. So even on other cloud providers. Then second thing, you have to make sure you install Istio, then install the Knative serving and eventing components. However, if you do choose to go this route, it does mean you're responsible for maintaining, for updating Knative whenever there's updates, and you have to make sure your cluster has enough resources to match your scaling requirements. But what if you do not want to handle all that? You do not want to run your own Kubernetes cluster. All you want, maybe you have a small team and all you really want is to run a container somewhere and not touch clusters at all. So that's where Cloud Run comes in. So it's a service by GCP, which allows you to run serverless containers. And it also uses the same Knative API, but the implementation behind the hood, under the hood, you don't need to worry too much about it, but it does not really use Knative. It kind of depends on the platform where you run Cloud Run on. So how do you deploy the Cloud Run? 3 steps, very simple. First, you have to write your application and you have to containerize it. So that means write application, write the Docker file for it, then build the container image and upload it to the container registry. Google Cloud provides a very handy tool for this. So you can try and use something called Cloud Build, which gives you a one-line command just to build the image and to upload it to container registry. So it's just gcloud build submit and the tag, image name. Next, you deploy it. So the last step would build the container image, send it to the Google Container Registry. So now with Cloud Run, you can pull the image from the registry and run it on top of Cloud Run. It doesn't need to be from the container registry. Obviously, you can use others like the Docker Hub. So you can see here, it's just G Cloud Run deploy, and there's something here called platform, which you have to state. So in this case, we're using the managed version, so we don't need to run any classes at all. So I'll show you a quick demo of how it looks like. Okay, something has happened. Okay. Right. So I have here a simple Go HTTP server. So essentially what it does is it prints hello world, and not too special. And here I have a Docker file, and that's all I need really. So what I'll do now is I'm going to send it to Cloud Build. Tag, and I'll specify it to container registry, and I'll give my project ID and a name for this image, and I'll tag it as version 1 because we'll be using different versions later. So this is what the Docker file looks like, and essentially what the Cloud Build command does is it will then build the Docker image, send the files over, build the Docker image, and then upload it to container registry. So as you see, it's now running it. So for those who don't know, Docker files essentially built layer by layer. So it goes through each of the lines of the Docker file, and it will then build the container up from layer by layer. So in this case, first it takes the Golang base image, builds the binary because Go compiles to binary. Then it copies it to then it pulls another base image, Alpine image, and then copies over the binary, and it runs it. So here I see it has completed. Okay. Oh, I see a problem. Here we go. I'm not sure if you saw it earlier. Okay, sorry. G-Cloud run deploy. So now I'm going to deploy the Cloud Run. So I'm going to give the service a name, and I will reference the container image that I have built earlier. In this case, using tag 1. Oh, sorry, I forgot something. Never mind, it will tell me. So, yep, I forgot to specify target platform. These are the available targets. We want the fully managed version, so I just enter 1. It's very handy. Then you state you want it unauthenticated because this is a demo and I want to curl it without setting up API gateways. So as you can see, now it is deploying the service. It's creating a new revision, routing the traffic, and setting IAM policy. And you can see now it is 100% of the traffic is served at this endpoint. So if I call this, we will expect to see hello world as expected. Excellent. So that was really easy, straightforward. You just need a Docker file and your code. So deployment options, you don't need to deploy it on the managed. If you do really want to deploy on your clusters, you can use Cloud Run for Anthos, which is Google's platform for hybrid multi-cloud development. So you can run it on your own GK clusters, your private Kubernetes cluster, and you can actually run Cloud Run on top of other cloud providers. I think I've heard of people running on top of AWS before. So that's how you would run it with this command line. So here you specify the platform. It differs for different, depending on where you deploy it, you would then substitute that here. So if it's managed, if it's GKE, then the dot means you have to add something else, so your cluster info, etc. Then auto scaling. So Cloud Run auto scales for you. It does scale to 0. So if people are not using Cloud Run, you are not paying for it. You can set the limit. The limit is up to 1,000 instances. And if you do need more, you can actually contact Google support and they will handle that request for you. But it doesn't mean that you can only handle 1,000 at a time because of something called concurrency, which I've talked about. Essentially, you can run one instance can handle more than one request. You can set concurrency. It's settable between 1 to 80. So if it's 1, it's not concurrent. So it's not concurrent, and each instance can only handle one request. So in this case, you see if there's 3 requests at the same time, it would spin out 3 instances, the green squares here. But if a concurrency was set to more than that, maybe let's say if it's 80, that means it can definitely handle 3 requests at the same time. So we deployed the code with Cloud Build earlier, but that's not the only thing it can do. So Cloud Build is actually a CI/CD tool for continuous testing, building, and deployment. So you can actually use it to automate your development. So you can connect it to a code repo, for example, and use something called Cloud Build triggers. So whenever you push to a certain branch, or if you have a certain tag, then it would then build and deploy the container image straight to Cloud Run. To deploy new revisions in Cloud Run is quite simple. You just have to change the tag. So same code, then you specify the tag here as slightly different. Here, the hash revision, or you can, if you label it like version 1, not 2, like what I did earlier. So just like that. So you can manage traffic. This is the UI. It's quite easy. If you have more than one revision, the UI would say that, and you can switch your traffic accordingly. So you can say, I want 20% to go to my new revision and 80% to my old revision. So this is handy for things like canary deployment, rollbacks, etc. So I'll show you a quick demo. So here I have the code from earlier, but I'm going to upgrade it. So instead of saying hello world, it's going to say hello world 2. Fancy. And now I will deploy it. I'm just going to do Cloud Build submit, and same thing as earlier, but I'm going to submit to Cloud Build. Instead of version 1, I'm going to tag as version 2. So now it's rebuilding the container, and it would then load it to container registry. So if you actually, all right, never mind. So it's still loading. Just see if I can go here to the console. You can have a look at the container registry, and it should show. So here it's finished building. So it should appear in container registry. This is the hello image, and you can see that's version 1 and that's version 2. So now we want to deploy it to Cloud Run. So it's this one here, but I am going to deploy version 2, and I'm going to give, first I need to specify the platform, which I had forgotten earlier. And I'm going to specify no traffic. That means I don't want any traffic going to my new instance. All I want is, I want the traffic to still go to the first instance. So it should still return hello world. I'm just going to get my URL from before. Oh, never mind. I'll just let it run first. So when that's done, you can see it's been served, and it's not serving any of the traffic. So I have a small script here, which requires environment variable. And basically, it's just going to call it 10 times. As you can see, it's still hello world. And the new instance is not running yet. So what we're going to do is we're going to go, I'll refresh this. So here you can see at Cloud Run, this is the Hello service. And I can manage traffic from here. So here I will let it show. Okay, so these are in 2 revisions. So this is the first one, the second one, you can see no traffic. I can manage traffic from here, and I can set the new version to maybe I'll have 50% of the traffic go to the new version, 50% to the old version. So you would probably expect half of the hello worlds to show hello world 2, right? So let's see if that's the case. So here the traffic has been split. And if you run, call it 10 times again, you should have some appearing as hello world 2. So as you can see, nicely it's split into half. Demo gods are with me today. And there you have it. So that's how you manage traffic. If you are thinking of trying out Cloud Run, there is a free tier, so you can find a container, look up some guides, and try it out yourself. I do have some resources for you, which I'll show later. So to recap, if you want to run container serverlessly on Google Cloud, you can use Cloud Run, which is the full, and it has a couple of flavors. Firstly, the fully managed version where you just have to deploy your containers and you don't need to manage the clusters. Secondly, you can run it on top of Anthos. So you can run your serverless side by side for existing workloads. You can run it on your private clusters, your GKE, or even on other cloud providers. And third, you can use Knative. So if you don't want to use Cloud Run at all, remember Cloud Run is using the same Knative API. But if you don't want to use Cloud Run, you can just install Knative on your own Kubernetes cluster, wherever it might be. So if you are interested in getting started, here are some links. I'll give you a link to the slide later. So they're quick labs. Make use of the 30-day free quick labs. And you have code labs, documentation, and there's a nice GCP podcast by Donna Malari, who will tell you a lot more about Cloud and GKE. And for Knative, the documentation is quite good, and I find the code examples by Mette Atamel quite good. So you can try that out. And that's all from me. Thank you very much. The slide links are here, and if you want to drop me and contact me, you can find me on Twitter. Thanks.
All right. Thanks for the talk on this Cloud Run and Knative. I mean, this whole thing is still a new paradigm for, I guess, for many people. Like, even though the term serverless also is new to the industry, people get really confused with the way like all your big tech companies try to muddle the meaning behind it. But before we let you go, I guess there's a question that kind of came up. I mean, I commented about it, but it'd be interesting to get a bit of your opinion on it as well. So the question was when to use VM versus container. So I think this one was like the earlier part of your talk. This question kind of came up. There are some, I put down some of my thoughts in the comment, but then maybe it'll be good to get some opinion from you as well.
Yeah, so I find containers to be quite handy because you can add all the dependencies on it. You don't need to worry about whether or not somebody has the right operating system for one thing. To, let's say you pass like binary or something to someone else, and then they're using the different operating system and it messes up. All you need to do instead is to just package it in a nice container, pass it to someone else, and you can run it. Containers actually, they, so I find that pretty helpful. VMs, I believe there are some workloads good for it. So, for example, many of the legacy applications, sometimes you can't, you shouldn't keep rewriting your code. So people are not paying for you. For example, your customers are not paying you for how nice your code looks like in the backend. They're actually paying you for the features that you are developing for, right? So even though it's really nice to have everything in fancy new containers, but sometimes all you need is just a lift and shift. So some workloads, they were built for VMs, so you can then, if you decide to go for a cloud, to use a public cloud, for example, you can then lift and shift it directly to the VMs there. So you don't always need to use containers, but for newer workloads, you might consider using it instead.
All right. Okay. I mean, that hopefully kind of answers that question as well. I mean, there are some comments that I added in the YouTube comments, so if anybody in the audience still wonder about it, you can add on to it. Okay, so I have a question on my end. I mean, I think earlier in the session, we did talk about this whole App Engine, Cloud Functions, and Cloud Run. But essentially, between Cloud Functions and Cloud Run, which is essentially almost application-specific tools, for developers that they just need to focus on the application. How does the developer distinguish when to use Cloud Function and when to use Cloud Run? I mean, seeing that they do sound similar, but I mean, yeah.
Okay. So Cloud Functions, they are essentially serverless functions. So if you have small snippets of codes that you just want to put somewhere to run serverlessly, you can use that. The nice thing about Cloud Function is it has a lot of, you can trigger in many different ways. For Cloud Run, it's triggered by an HTTP endpoint, but for Cloud Functions, if you're using Cloud PubSub, for example, the messaging system, if you're using GCS, you can, it's really easy to just set how you're triggering it. You're triggering from a cloud storage bucket, you are triggering it from the PubSub, and that's easy for you to set. So another thing is Cloud Functions, it offer, you can only write it in several languages. So Java is the new one, right? Then there's Go, Python, Node 10. I think Node 8 is being deprecated. And so if you are thinking of using another language aside from these four, you might want to consider packaging your code up as a container and running on top of Cloud Run instead. Another thing would be concurrency, because Cloud Functions do not offer concurrency. So the concurrency is forever set as 1. So that means if you have a lot of requests, they'll have to spin out a new function every time. So Cloud Run instead, the concurrency can be set up to 80. So you can use that. One more thing is, if you're thinking of using this, ties into my second point, but if you have things like random things like a binary, for example, you can run it on Cloud Run. Cloud Functions is a lot less flexible.
All right. Okay, then we have another question that popped up in the chat, YouTube comments. So let me put it on screen. So could you maybe comment on Docker Compose versus Kubernetes? When is it small enough to use Docker Compose? Yeah.
I've not actually used Docker Compose that much. So that might not be a good question for me to answer. Would one of you like to take it instead?
Okay. Wei-Yan, you were about to say you can answer it first.
Okay, I've used both, so let me come to it in a different angle. Okay, I would say this is, in fact, someone asked me this one question today, it's kind of related to this, and I'm going to use that as an analogy. So the person asked me, why do we choose Go over Rails? And basically, I just gave an answer, which is, in the end, yeah, you can compare, there are some facts and everything in in terms of the scheduler, for example. But I think in the end, it comes down to human experience, human preferences. What is the organization most comfortable with, and they will usually go with that. I mean, in the end, you also want efficiency in terms of your engineers, in terms of getting your workflows, your pipelines moving properly within a company. And I think one thing I can share is that in our company, we use both, but we use both tools to sort of enhance our experience in development. So Kubernetes itself, orchestration for and controlling your workloads in production in a staging environment. But what if you want to run it locally? Locally, we just use Docker Compose. It's very easy to set up. One single YAML file, just put a few configurations. For example, I have my application, I set the Docker file there, and then I need a Postgres dependency. I'll put it in there as well, Redis or whatever. So I don't need to go through like the nitty-gritty, like setting up all the configuration for maybe if you need to use Minikube. I haven't used it that much, so I can't comment on Minikube. But the thing is, for us, it worked very well using this setup. Basically, Docker Compose in development, and then Kubernetes for our remote environments. Yeah, so that's my answer for that. Horizon, I think you have something to.
Yeah, I guess the angle like being answered here is more of the colleagues that we work with. So I mean, because to some people, adding Kubernetes on top of whatever that they have to do is actually quite a painful experience for them. Like throwing them Docker is already one thing. Learning Kubernetes is a whole new ball game. So in terms for at least for the bigger companies, just adding Docker is already good enough to get things rolling. Like let's say if the stuff in production is already in Kubernetes, like just getting developers to adopt to Docker is already a good enough measure. Like giving them like telling them to go and set up like Kubernetes and everything is actually quite a hard thing right now, at least from what I see, at least in Singapore. But let's say if we are to put, if you were to take this and just answer it straight on like that, like let's say if you do it to production, like Docker Compose versus Kubernetes, right? Like I do see some issues like running Kubernetes for like 2 or 3 apps. Like imagine like setting up like proper cluster for it. It's quite expensive. So to me, my own opinion, let's say if you're trying to run Docker Compose on production versus running Kubernetes, running your applications on Kubernetes on production, right? I think it really boils down to price. Like, which one is more expensive? Like maybe throwing all your containers into Docker Compose, maybe it might not be good for the long run, but if it's like 2 or 3 times cheaper as compared to the Kubernetes option, yeah, then we'll take that option. Because I mean, Kubernetes comes with a lot of overhead, and especially now, I think recently GCP raised its price for if you want to have more Kubernetes nodes. So a more Kubernetes cluster rather than Kubernetes nodes. So yeah, I think price is really a big determinant here. But that's my opinion, I feel. So when it's small enough, like when it's too expensive to run Kubernetes, I think Docker Compose is fine, good enough for that.
Maybe if I can.
Then.
Okay.
No, you can jump in here.
I just want to put in one more thing that I kind of just thought of, which is like if you're on GCP, if you want to have, if you want to use Kubernetes, you have GKE. For Docker Compose, I would say that your option is you have to set up your own like a bunch of VMs and basically just run Docker Compose on it. If I'm not wrong, I haven't run it in production before. So there's a lot more that your DevOps teams will have to do in terms of setting that up, and in terms of setting up, let's say, your entire CI/CD pipeline to deploying to that, your cluster pool, essentially, or your node pool, and you have to set in all these things yourself. But all of this comes already sort of for free with Kubernetes. It already comes in together with GKE. So I would say that's also another push point to using, if you're using GCP or AWS, I think they have their own variants of the Kubernetes engine. So it's definitely a lot more easy to use.
Yeah. So hopefully that answers this question. I mean, the poster here also added a few more comments where, like, let's say if the Docker Compose was in production. So I think that kind of hopefully answers the whole Docker Compose in production and everything. Yeah. So let's move on to another question. I mean, it's not exactly related to today's session, but I think let's try to cover it as well. So, is it okay for a container app to be connected to backend on VM? So, can I take from the angle where the container app here is like a cloud run app? So, seeing you want to give your take on it?
So I take it that you are trying to run a container on a VM and then connect it to a backend, maybe. Normally you would run, because it's much easier to just orchestrate it. That way you can just run it on like Kubernetes, you can run it on Cloud Run. You might run it on Container Engine, but I'm not sure if you would normally run it on the VM, although I think I've heard of people doing that before. It might be better for normal use case to run it on Kubernetes instead, maybe, or one of the other options. Could you give clarification?
Yeah, I mean, it'd be nice if the person that posted this question, it would be nice if you add in more details. Then we'll try to answer the following questions after that. Because like right now, it's kind of vague. Like, container app. Like which specific thing are you referring to here? Like,
maybe your backend might be the app that you're trying to run on the container. Like you're splitting a backend into different services and you're running down your containers. So if you want to clarify a question, that might be bad.
Yeah. All right. Let's wait. Like if you will post more specific questions to that, or more specific comments to this. So there's one question. I mean, more like kind of like opinion, I guess. Like if you could get your way, what additional feature would you want to see being added to Cloud Run?
To Cloud Run.
Yeah, I mean, yeah, I mean, like more like a wish list, I guess. Or is it perfect as the way it is?
The recent release made it better.
I feel like you have there's something in your mind, Horizon, that you would like to have on Cloud Run. Is there something you want to add?
I mean, I do have my opinion on it as well. I did hear. I mean, this thing that this whole Knative thing. Yeah, I mean, this whole Cloud runs on Knative, right? I mean, correct me if I'm wrong here.
Yeah.
So, I mean, I did see in Knative they was saying about tech versions of this of applications or revisions. Like, let's say if I want to okay, because just now you were showing the revision, like 50% of my traffic goes to application version 1 and 50% goes to version 2, right? So that kind of gives you some sort of like canary kind of deployment to test whether your new app version can take it. But like maybe let's say if you develop this specific feature and like you only want this specific person in your company to be able to access it in order to like do like manual QA, kind of wish like
so you probably have like a code repository and certain people have access to it. I think you could do that with the Cloud IAM policies. You can set because if you can tag it separately, so maybe you have different features, you can tag it separately. You can set Cloud Build, right, to deploy it upon receiving a certain tag. Is that what you mean? And then
yeah. Like this tag version. I mean, I saw Knative has it, so seeing that Cloud Run is based on Knative, so
I think for some of the things like for inventing, for example, Cloud Run actually in this case, inventing, it can you can receive messages basically from PubSub, from other sources. For Cloud Run, it's actually not completely Knative under the hood. It's using the same Knative API, but Google has its own implementation of Knative under the managed Cloud Run. For the GK instances, it might be a different case. They might be just installing Knative directly on it. But for the managed Cloud Run, it's actually not purely Knative. So sometimes you have to do different things to route around it. So in this case, you might connect Cloud Run to your PubSub and use PubSub as endpoint, basically. Something calls trigger to send a message to PubSub, and then PubSub triggers the Cloud Run, for example.
So these features are already available in GKE. Wait, I mean the Knative on GKE. Is it?
Perhaps I've not used that as much. Normally I just stay with the managed version because that's enough for me.
Okay. I mean, this one is more like wish list for the managed one, because I'm on the lazier end. Like, why do I need to set up all this?
It's actually not that difficult. Yeah, if you really want to just like build a cluster, you just have if you go to at the end of the slides, there was over here, I think there was a link with the core examples. This guy is, I think, a developer advocate at Google, and he basically runs a lot of he basically regularly needs to load Knative install Knative onto his clusters. So he has some really nice code examples. You just have to change the config files, and then it just update. Of course, whether or not you want to keep a cluster running is a different story. So otherwise, you have to do workarounds with the managed version.
All right. Okay. So we have a clarification to the question just now. So let me reiterate the first comment, and then the more specific comment to add more details to that question. So the comment just now was is it okay for container app to be connected to backend on VM? And then the comment to to give more details to it is Docker container app here refers to a Postgres database running on a Linux VM on GCP.
Okay.
So I guess it's not exactly it's not a Cloud Run specific question, but more of a container question, I guess. So the container app here is Postgres database.
Wait, the Postgres is running on top of the VM though, and you have a container app which is connected to the backend on the VM. So you have a container app which is separate, and you have a VM which is running your Postgres database, which is your backend, I assume. That should be fine. It's just this normal connections. I don't see any issues.
Yeah.
You need to worry about the connections, because I believe for databases, it does only support a limited number of connections. So you need to make sure the number of, because Cloud Run is scalable, so you can scale up to 1,000. Your Postgres instance database might not be able to handle 1,000 requests plus concurrency. Concurrency, there's like 80 requests at the same time. So you might be sending more than what Postgres, the limit for concurrent connections on the Postgres database. So that's where the maximum invocation comes in, because for Cloud Run, you can actually set the maximum number of invocations. So you can set concurrency just to make sure you do not blow past the limit and you have too many in connections to the Postgres database at a certain time. Does that make sense? I think.
Yeah, hopefully that kind of answers the posters question. Although I just do want to add where generally people, I mean, when it comes to databases, like people don't generally run it within Docker containers. I mean, you can, like nothing stopping you from doing that. But then, like I will usually have concerns about it in terms of, because at the end of the day, you need to write your data out, and then
Oh, sorry, I thought the Docker container app is like maybe a front end or something, and then the back end is the Postgres database.
Oh, I
I
thought
might be
the Docker
confused.
container was the Postgres. Okay, maybe I got confused here.
I'm not sure, but well, we have two takes here, so we covered everything probably.
Okay, but okay, like I guess I'll cover my point. So we'll cover from two angles. So I mean, hopefully that answers both questions. Like if the guy has any concerns regarding like one area or the other. So let's assume that we interpret this question where the Docker container app here refers to the Postgres database. So generally, like if you are like storing state and stuff, like you wouldn't want to store it within database. I mean, because at the end of the day, there is overhead when it comes to writing the data out. So it'll be ideal if the thing is in VM. Like, I mean, I do have like reasons for it, but like it's kind of vague. I don't exactly know how to like make how to verbalize it. But yeah, I'll add it in the comments after this thing. Like if I find any resources on why it's better to run it in VM rather than container. Yeah, but it depends on use case, I guess. I mean, if it's a light load, should be fine. Yeah. So
Maybe I can just add one more sentence to that. Just to tie back to the GCP part of things, which is I would very heavily recommend that you try out Cloud SQL, which is to manage. I mean, they support up to. In fact, they just Postgres 12 just went GA, so that's like a really great thing. If you use Postgres a lot, you want to update to the latest version. You want to use some of the the modules or plugins that comes along with that. In fact, they added a few more of those plugins as well. So the manage Postgres is pretty awesome tool to use. And I think to like answer some of the questions that the other speakers have mentioned is like, let's say limited connections to the database. If you need to scale up using Cloud SQL, it's really easy. You just need to go into a menu and just scroll up your RAM upwards. And essentially, because the RAM will translate the amount of connections you can make. So, I mean, if you have reached a scale, if you have reached a limit, just scale it up like that. But if you're running in a VM, right, you have the more troublesome part of like, okay, now I need to get my files dumped out somewhere. I need to now provision a larger VM and then add more things there. So it's a more troublesome process in having to upgrade or even maintain, on your own VM. You rather use a managed variant of that instead.
yeah, I guess like you can just say if there's a managed version, use the managed version. All right. So hopefully, I think that's all the questions or comments. Yeah, don't exactly have anything else to add. Wayne, you have any like questions that or comments that or opinions you want to add on to this? Add on. Yeah.
Yeah, I'm cool. I think all the questions were really good. Really excited and heartened to hear from the community in terms of the questions they have to ask today. If you have more questions, yeah, I think just now I also posted in the chat in regards to our Facebook group. So if you have more questions that you couldn't get to ask, feel free to just ask over there in our Facebook group.
Yep. So with that, I guess singing. Thanks for your sharing on Cloud Run. I mean, it's always great to get like sharings regarding all these resources and everything. Because like Cloud Run essentially is still a very very young product. So like I mean, more people talking about it. Like hopefully that translates to more features that might manage on Google side. So it gets more exciting along the way. Yep.
It was released last year, right? I remember thinking just before the release, it's nice having cloud functions, but where are my serverless containers? And then boom, out comes Cloud Run. Perfect.
Yeah.
Can't wait to see what's up for Cloud Next this year.
Yeah.
And thanks for having me this one.
Yeah, next month. Cloud Run Next is next month. Yep. All right. Thanks, Singyi. See ya next time.
Yeah, see you. Thank you. It was a pleasure.
Yep. See ya. Okay, let's proceed on. Back to our usual.
Yes. Right. So we're reaching the end, but don't go yet. Like we have exciting news. I mean, we talked about it earlier on, but in case you missed it earlier, just to reiterate it again, go to this link, Google /GCP cert offer, and go through the steps. So you have to apply for the associate cloud engineer certification. And once you have done the quest that we mentioned earlier on, let me just rewind a little bit. Okay, so you can see over here, you just need to complete the cloud engineering task, and you will get a discount, a 30% discount for the examination. So, yeah, this is up for 30 days until June 30th. So, yeah, register by June 30th. So, if you have not yet done the associate cloud engineer examination, and you have been keen to know what to do that, please go. This is a very good opportunity, and the examination doesn't need to be at the test center. You can actually do it online. So, yeah, really excited to see you guys taking our certification. Share with us your successes in time to come. Okay, let's go back to where we were at just now. Okay, so Cloud Next. When is Cloud Next? We went past April, things blew up. It sucks, but no choice. We have to postpone it. So Google has postponed Cloud Next. Now there's an online variant. It's going to be in July 14, as seen over there. If you're interested in joining us in the festivities for Cloud Next, you can go to this link over here, cloud.google.com/next/SF. So you'll be able to choose from like 9 different tracks over the course of 9 different weeks. Okay, so if you are interested in any of those tracks, do make sure you sign up for those, okay, and just turn up for those online events during those weeks. And lastly, again, courtesy from our speaker, she shared with us a link leading to a code for a 30 days free subscription to Quick Labs. So if you like Quick Labs, I like Quick Labs a lot. I applied this and I got 30 days. So I'm very happy. I'm going to do like a few more Quick Labs later. And if you're preparing for your certification exam, do go for this. Free 30 days. It will extend on to, earlier I mentioned about the certification offer. It will give you 30 days. This should add another 30 days to that. So you have like 2 months, not just 1 month, 2 months for you to prepare, to try out different labs in Quick Labs, to try out and understand, the different concepts in GCP. Okay. And this is the end of webinar 5. So, sorry, webinar 4. Okay. The next one is webinar 5. So we have this like very sick image over here. But basically, yeah, the theme of it is going to be building an ML-based KYC system. Okay, so regarding ML, that's why you can see it's kind of like machines all over taking over us. Yeah, so we hope to see you guys then. This is going to be 2 weeks from now. The same Thursday as well, from 7:30 p.m. to 9 p.m. All right. Okay. All right. So I'll hand over to Harizan.
Yeah, I'm gonna do a random plug here. So so I think my company will be giving a talk sometime next Thursday. Like I'll be involved in this as well. So it's like if you are interested in the Kubernetes related topics, there will be a meetup next Thursday. The link to that, like you can see there, or you can just go to meetup and find for Singapore Kubernetes user group. So I'll be involved with the talk, the first talk, talking about scaffold. So I think this is one of the topics that is kind of covered like once or twice already. But I mean, if you go to YouTube, you can probably search on it. But we'll also cover it one more time. In terms of the experience of using scaffold, at least in Acronis. So if you're interested in that, see you there. But also the other talk is also pretty interesting, where there's this mention about cluster API with Kubernetes. So it's kind of a brand new thing. I think there was like a huge amount of development over there. Like I think they created an API and then they realized that the API isn't good enough. Then they kind of recreated it or something. I know it's a long story. So hopefully, if you are interested in that, those kind of stuff, like you can come down to this. Okay, don't come down to the meetup location, but go online and find the meetup and go to the Zoom link available on this webinar. Yeah, so just go and register, and then you can get the Zoom link, or maybe it's already there already. Yeah, you can go and check it out.
And as always, so this is together with collaboration with GDG Singapore. So if you're interested in talking about related cloud topics on using GCP, if you have experiences in a workplace that you want to share with us, share with the community, on how you solve like this sick problem that you had over the last few months, jump over to this link. Wait, you're pointing to this side, bit.ly GDG SGCFP. Yeah, it's actually the opposite direction for me.
Yeah, opposite direction.
So yeah, go into that link. It's not just about GCP alone. If you have like exciting topics to talk about, your experience with Chrome, you're a web developer, you can go ahead and apply for that. TensorFlow, Android related stuff, all the Google related topics, you can go to this link over there and yeah, just sign up for them. And you can leave this like for 5 seconds more. Okay, 3, 2, 1, and that's it. So yeah, follow us. Like I think just now someone was asking about like our Facebook group. So I pasted in the chat earlier, but yeah, if you want, you can also just search for our group over here. We regularly will try and post articles, informing regarding like latest exciting news regarding GCP. Like one of the things we talked about previously, the poster I believe was on like Redis, not Redis. Sorry, the being able to set the VPC connector with Cloud. Is it Cloud Run? Yeah, Cloud Run. So previously you couldn't do like things like manage Redis with Cloud Run for a long time. Now you can do that. It's like, oh my god, I'm so excited that they finally allow us to do that. Anyway, so yeah, hop over to our Facebook group. Again, wrong side. Facebook group.
Yeah.
And we have our Slack channel as well. And definitely, our meetup page. Sign up for that to get notified on our next events. We might be doing more than webinar as well. So, yeah, sign up for these things and we'll stay in touch. See you guys in these different channels. All right. And yeah, for those in YouTube, just additional plug. If you like the content we are doing here, or if you have feedback for us, leave it in the comments. And make sure you like, share, subscribe to us. So you get notifications on like the next webinar that we'll be doing. And from those in Facebook, I believe you like our video. Give us feedback on the chat as well if you have any for us. And yeah, so we have reached the end. I'll see you guys next time.
All right.
Bye.
See ya.